Welcome to the deep dive. We're here to pull out the key insights from some really fascinating sources for you. Today, we're diving into the world of maps, cartography. It's amazing how they've guided us, hasn't it? From, charting huge unknown lands way back when to the incredibly detailed digital maps we all carry around in our pockets now, whole libraries shrunk down.
Absolutely. And maps have always done fundamentally two things. First, help us understand the world around us. But second, and this is key, they've helped us shape it. Planning cities, trade routes, even running military campaigns or trying to keep the peace. They were tools for action.
Right, tools for action. And now they're digital, super accessible, but there's a bigger shift happening, isn't there?
Yeah.
We're apparently moving out of the, quote, information age and into something called the cybernetic age.
That's the term being used. Yeah, it's about applying things like robotics, AI, directly onto the physical world, not just information, but physical interaction. And that demands a completely new kind of map making, a new cartography.
So just looking at digital maps isn't enough anymore.
Not quite. I mean, digital collaboration is great. Observation is useful. But the real challenge now,
Yeah.
the imperative,
hmm
is using these technologies to physically build. And, for the first time ever, really, we have the sensors, like up in orbit, and the computing power needed to process all that data, enough to create this dynamic, living replica of Earth inside a computer. It's being called the living globe.
A living globe.
Yeah.
Wow. That sounds huge. What does that actually look like in practice?
Well, you can think of it like a giant digital sandbox.
The sandbox.
Yeah, where you
Yeah.
combine this constantly updating digital version of the planet
Yeah.
with real-time sensor feedback from the actual ground.
Okay, I think I get it. So our mission today for this deep dive is to explore how this living globe helps us move past just watching the world to actually, shaping it and maybe tackling some of those really big physical challenges we face.
Precisely. That's the goal. Let's maybe take an example. Think about the Los Angeles wildfires earlier this year. Satellite images, mapping tech. They were absolutely crucial, no question, for understanding how bad it was, guiding the first responders, seeing where the damage hit hardest.
Yeah, you saw those images everywhere. Incredibly useful for situational awareness.
They were. But here's the crucial point. Looking, observing, reacting.
Yeah.
It wasn't enough. It showed the devastation, but it couldn't, deliver the water needed or build the fire breaks fast enough. What LA really needed in that moment wasn't just more pictures, it was physical stuff. Big infrastructure maybe, or even autonomous firefighting robots on the ground. Action.
That really drives home the limitation, doesn't it? Observation versus action. And it makes you think back maybe, 200 years ago? We were much more of a civilization of builders, right? There's this culture of action.
There really was. Think about the Erie Canal, the Transcontinental Railroad,
Yeah.
the Hoover Dam. These were massive projects. They literally reshaped the physical landscape.
Absolutely huge undertakings.
But, and this is a big but, they often had, pretty devastating consequences down the line. Side effects we just couldn't predict back then.
Because we didn't have the tools to see the full picture, the long-term impact.
Exactly. That lack of foresight, that inability to predict the knock-on effects, kind of led us to pull back, didn't it? We retreated, in a way, into the virtual world. iPhones, PCs, a more individual focus.
Yeah, safer perhaps, but less ambitious physically. And yet, look at the problems we face now. Climate change, energy getting enough of it cleanly, housing costs, global security. These are all fundamentally physical issues, aren't they?
They absolutely are. They're problems of moving atoms, as one source puts it, moving physical stuff around.
Which brings us right back to needing that builder's spirit again. But maybe this time with more intelligence, more foresight.
That's exactly the idea, and that's where the living globe comes in. So how does it enable that smarter action? Well, what it does is fuse together just dozens and dozens of different kinds of data. Satellite images, climate models, population data, infrastructure plans, you name it, all pulled into this dynamic living picture of the Earth. And crucially, it's structured using what's called an ontology.
An ontology, what's that?
It's basically a way of defining the data and the relationships between different pieces of data so computers and people can understand it together. It creates a common language. This allows AI, for example, to programmatically find complex patterns you'd never spot by looking at data sets one by one. And you can delegate the monitoring, let the computer watch for changes.
Okay, so it's not just a pile of data, it's an integrated system that can find insights. Let's make that concrete. The sources mentioned Vancouver as an example. They combined tree data with housing data.
That's right, Vancouver. They layered tree height data, vegetation data from Landsat satellites, and information on affordable housing districts.
And what popped out when they did that?
Well, what was really powerful was how it allowed them to quantify things. For example, you combine heat data with the tree canopy data, and boom, you can clearly show, numerically, how much those trees reduce the urban heat island effect.
Okay, so proving something we kind of intuitively know, but with hard data?
Exactly. But it went further. Two key patterns really stood out. First, trees clearly correlated with economic uplift, higher property values, more business activity. People really want to live near trees, and the data showed it. And second, just how critical trees are for, building a resilient, livable city overall. The Living Globe turned anecdotes into measurable value.
That's really interesting, moving beyond trees are nice to trees provide X amount of cooling and Y economic benefit. But you said it's dynamic. The goal isn't just a one-off analysis, right? It's about real-time updates. How does that work?
Right. So you have all these satellites constantly orbiting, constantly taking pictures, dozens of them. That constant flow lets us shift from just making a map of how things were to continuously monitoring how they are. Right now, you can build essentially an instrument panel, a dashboard for the city.
A dashboard for the city. I like that.
Yeah. It lets you understand the whole city or region in real time, and that changes everything for planning. You stop thinking about projects in isolation and start seeing the city as this interconnected system. How does this project affect that goal over there? You can aim for multiple goals at once.
So instead of just looking at, say, building permits issued, you can actually see the construction happening.
Precisely. Permits tell you intent, maybe. But satellite imagery, combined with change detection algorithms,
Yeah.
that shows you where ground is actually being broken. Now, you can literally zoom into a construction site in Vancouver, watch the development happen week by week. You can use infrared sensors to see how vegetation is changing, are trees growing, being cut down, blossoming.
Wow, that's incredibly granular.
It is. And it provides immediate feedback.
So taking that Vancouver example, if a new apartment building goes up and they have to remove some trees.
The Living Globe would flag that instantly.
Yep. And then what's the action?
Well, the insight is, if the city has a goal, let's say, to increase its overall tree canopy or maintain it, and this development takes some trees down, the system can then help figure out the best place to plant new trees to compensate. Maybe, like we mentioned, up in that affordable housing district to the north where they'd provide shade and other benefits.
Ah, I see. So it connects the specific action back to the larger strategic goal.
Exactly. That's what we mean by using maps to build. You create this live dashboard, this instrument panel that tracks change over time. Not just where things are, but the trends, the metrics, the measures that let you actively guide development towards the outcomes you want.
It feels like this could help us escape those really difficult trade-offs we always seem to face. For decades, the debate felt like it was just build this thing versus don't build this thing.
That binary choice, yeah, it's often felt that way. But really, the promise of good technology, deep technology, is often about eliminating those trade-offs. It lets you find ways to do more with less, or to achieve multiple goals simultaneously that seemed contradictory before.
So the Living Globe isn't just like a better mirror to see the world.
No, it's much more than a mirror. It's potentially a canvas where we can visualize a better future, understand how to get there, and maybe, just maybe, summon the collective will and coordinate the action to actually build it, to make it physically real.
That's a really powerful way to put it. A canvas for a better future. What an incredible deep dive this has been. This Living Globe idea, it really does seem like a fundamental shift, moving cartography from just observing to actively shaping what comes next.
Yeah, the potential is there, the power to analyze, predict, and then, crucially, guide the physical actions needed.
It definitely offers a new toolkit for tackling these huge, complex physical problems of the 21st century, fostering that builder spirit again, but a much smarter, more informed version.
An ambitious spirit, yes, but coupled with unprecedented intelligence and foresight. That's the hope.
So it leaves you thinking, doesn't it, for you listening? What physical challenge in your own town, your own community, how could that be transformed if you had something like a Living Globe at your fingertips? Something to ponder.